Yeah, hi everybody. Uh, I'm doing a recorded lecture in anticipation. This is the evening of the 27th. I know we have class on the 28th, but I don't anticipate I will be able to be there. We will have class on site on the Thursday with lecture in the morning and lab in the afternoon as planned. So that'll all be good. But I beg your pardon. But the lecture for tomorrow, I don't believe I'm going to be able to make with just a lot of things going on here at home. Though thankfully, nothing really significantly problematic. So, without further ado, I'm going to take you back to where we were. And the last thing, and if you're like me, I had to look it up, so that means I didn't look at it when we were on break. We were looking at this, which is the urinary system. And if you go back to the last thing that I posted, and if you did not receive it, please let me know. Or if I did not post it, let me know. And that really took us roughly to here. Okay. This is the last slide that I have on my notes, and this is basically the discussion of the blood vessel and blood supply to the kidney. Kidney's relatively complicated, and I don't really want to go into everything here. But effectively, this is where I left it. And the first unique thing is that you have arterial blood coming in and arterial blood going out. And that in itself is unusual because we rely on pressure. Remember, effectively, it's a high pressure filter. And with a high pressure filter, as long as the pressure is there, and that's the big problem with the kidney, is that if the pressure, and I'm walking away from the computer for just a second, if the pressure dissipates, then the difficulty is that the kidney doesn't function. So the goal of the exercise is to make sure that the kidney functions consistently and strongly throughout. And effectively, that's kind of what we're looking to achieve here in this format. So moving on, what happens is once the filtrate is produced by going round and round through this nest of capillaries, which you're going to see shortly called a glomerulus, at that point, the filtrate, which is effectively all the water, other than enough to keep the blood and what's left, the red cells, white cells, platelets, and proteins flowing uh, out through the efferent arteriole. Then eventually, this nest of capillaries, either peritubular capillaries, which you're going to see shortly, again, which are in the cortical area, the vasa recta, which are in the medullary area, and the peritubular capillaries, they process and they effectively the tubules process, but they capture back almost everything that has to come back, and it even gets rid of some, bring stuff in it's going to get rid of later to create gradient so it can flow easily. And the vasa recta are mostly about water, but they have to bring back some salt in order to continually balance it out. And then finally it goes out by way of the veins. So the unit that really does all this is called the nephron. There are two parts of it, the tubule system and the corpuscles, which is really where we see the nephron. You're going to see that shortly. So it's a tuft of capillaries that are very porous, and they're all what they're called fenestrated. So the little capillaries have windows, and you'll actually see a micrograph that reflects it. It's a pretty well understood system. And so that filtrate, which is all that fluid, save the formed elements of the blood and the proteins, are really what eventually is going to be 99% reclaimed. And what's left, you and I call urine. So the capsule that surrounds this nest of capillaries is called a Bowman's capsule. And it's like the start of the top of a funnel. It's like you put something in, like you put like the end of a hose into a funnel and you start spraying it. And that funnel is really the Bowman's capsule. And yes, it has a couple of different layers, but basically it's lined with simple squamous epithelium. And it has surrounding it, it has these interesting little processes that can kind of adjust the little slits. So you can either, it's like if you have maybe you have one of those old fashioned coffee filters where you can almost, they used to call it dial a brew. You can make it smaller if you only wanted 2 to 4 cups, or larger if you wanted 8 to 10 cups. So imagine that's kind of the analogy for that. And so they're showing you these are the little openings that can be controlled. And even there are tiny little holes and little openings that are surrounding it. And so the stem of that funnel is like a twisted stem, like you bought one of those kind of fun straws that had all the twists and turns. You put it into the drink. The stem of that funnel is twisted, and so they give it the name convoluted tubule because convolutions are the twists and turns. That's what starts at the end of the capsule, the Bowman's capsule. It goes into a loop that's either relatively short or very long, called the nephron loop. In the old days, we used to call it the loop of Henle, capital Henle. It's a proper name. And then a somewhat smaller amount of convolutions, but still convolutions, called the distal convoluted tubule. And eventually, multiple ones of those flow into something called the collecting duct. And you're going to see that. Proximal convoluted tubule is pretty darn busy. It has lots of microvilli, that surface area, just like we had in the gut, and lots of mitochondria, because this is where the vast majority of bringing back in the stuff that we don't want to get rid of and getting rid of some stuff we don't want to keep, as well as bringing back in stuff that eventually we're going to get rid of just to develop a concentration gradient. And all of this occurs in the cortex, the outer portion, so to speak, of that uh, the kidney, the organ that we call the kidney itself. And here you can see all of that abundance of mitochondria and the abundance of microvilli. The loop really has a thin descending limb that's mostly about water, and a thicker ascending limb that's mostly about reclaiming electrolytes. Okay. And it's more significant when we look at it in what's called the juxtaglomerular, I beg your pardon, what's called the juxtamedullary nephron, because those long loops are where water is concentrated. And probably won't get necessarily into a ton of that today, but maybe a little bit. And then the distal convoluted, and here's what the loop segments are nothing really special. The distal convoluted tubule, again, cuboidal cells, but what's interesting about them, they're more secretion than reabsorption, so they don't require quite as much mitochondria and quite as many microvilli. So they're busy, but not quite as busy. Remember that really the three major components of kidney are filtration, and then reabsorption in the tubes and secretion in the tubes. And I always add a fourth when we concentrate the water in the loop system. So hopefully you'll be able to see that as well. So this is what I mean. These are typical loops, simple cuboidal cells, and here's the opening or lumen. Here's this nest of capillaries, and the lining here is the capsule itself. And I mean, there's different kinds of cells. I don't get too caught up in that. And the collecting ducts are a long duct that gets multiple entry points. Remember, in each kidney, you got about 1 million of these glomeruli of the different types. So they're, really very, very busy, comparatively speaking. So I think that's something else to pay attention to. And eventually, all of those collecting ducts and all of the loops really give it that striped appearance that's so characteristic of kidney. When we take a look at it, both schematically and in a dissection thing that we're actually going to probably do on Thursday, a little dissection thing as well. So I thought I'd bring that up as well. That's there. And so you see this illustration a lot. Here you can see the incoming, the afferent arteriole, which is wider than the efferent arteriole. You can see the capillary nest inside the yellow Bowman's capsule. And that's what I meant by that sort of twisted straw, convoluted tubule, a loop, thin going down, thick going up. Another loop, not quite as convoluted, and multiple entry points into this collecting duct. So the loops, particularly the long ones, and the collecting ducts give it that striped appearance. Now, this is all spread apart from side to side. It's not so spread. They're very, very close together, as you will see. So the different nephrons, about 85% are in the cortex. They're basically reclaiming electrolytes, sugars, other chemicals, and getting rid of waste products. The juxtamedullary nephrons, only about 1 out of 6, have the really long loops that go all the way down, almost all the way to the bottom of where that minor calyx is, and they're really all about concentrating the urine. They become something that I'll cover later, called the countercurrent multiplier. You're going to see it makes a real long hairpin turn. And the fact that urine's flowing in one direction and blood's kind of flowing in the opposite direction create an interesting current that allows the urine to be concentrated. And something that as babies or during gestation and as they're born, they don't have that ability. It develops over time. So babies are constantly urinating because they can't concentrate their urine. But every time they produce urine, they do so frequently, they start to create this interesting concentration gradient. And that's pretty cool. Now, here they are not so separated. Here you have a typical cortical nephron, the vast majority. The bluish color surrounding the yellow are that those peritubular capillaries, they're sucking back up, so to speak, all of those chemicals that have been reclaimed for the most part. Okay. And yes, some of them are left in there and some will be pushed out again, but you can see the loop's relatively small, thin and then thick. Okay. Here's the juxtamedullary, juxta means next to. You don't see the capillary beds around the convolute tubules. They're all around that long loop, that nephron loop, thin, and that's basically water coming out, boom, 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 boom. And as it comes back, in order to balance out the fact that you lost the water, now you have an abundance of salts. Now you have the salts being pulled out. Effectively, that's what happens. And that flow is such that it creates this hairpin turn, creates this counter current. It's very, very concentrated down here with all the water coming out, and it's reduced up here. And we're constantly doing it. And that takes, a fair amount of time. Think of how long it takes for a baby to be potty trained. And effectively, this sort of coincides, particularly with regard to their ability to concentrate urine as much as anything else. So again, you have the renal tubules basically go out of the glomerulus, and you have peritubular capillaries, and then of course you have the vasa recta. That just means straight vessels. Those long loops are, as you can see, quite straight, sort of draped over that long loop. So the glomerulus is all about filtration, entering afferent, leaving efferent, but again, it's still arterial blood because the pressure is what allows it, is what forces it through. It doesn't have to waste energy creating an additional force to create the filtrate. Okay. And the afferent's wider, as you can see. They have a lot of resistance. The peritubular capillaries are very porous, so they suck back up a fair amount of the water and a fair amount of the solutes, the stuff dissolved in the water.